Before I start, I would like to acknowledge that the work I'm presenting has been carried out on Wurundjeri and Boonwurrung country, and I pay my respect to their elders past, present, and emerging. I also respectfully acknowledge First Nations people joining us today, their ancestors and elders, and their connection to country. All right. So overall, a search begins when a user realizes their inability or insufficiency to solve a problem, prompting them to use a search engine, then querying and assessing the search results and evaluating the information quality. For decades, information researchers have been trying to understand how users seek information. They have proposed these models, which describe the information seeking process in considering the interplay with cognition and emotions at each stage of the action. These past models have traditionally been formulated based on observational studies or self-reporting or facial expressions. To capture a more fine-grained picture, we can also look at physiological data that responds to cognitions and emotion. For example, increased heart rate when we read something interesting. With advancement in technology, physiological sensors are becoming smaller and embedded in wearable devices. Last year, Apple has published these new patterns of AirPods with brain sensors. So these devices are going to become more ubiquitous in our life. So can we also use them in information seeking? Well, it's not that straightforward. And yes, there are existing words that already apply the sensors but on individual search stages. Search is a sequential process of retrieval, read, evaluation, or appraisal, and then repeat, right? So physiological data and also physiological data are highly sensitive across tasks and individuals. So let alone the wearables are not as accurate as the medical devices. So therefore, as the first step, our paper looks at the search process and tries to validate the past search models using physiological data that captured using the wearable devices. To achieve this, we first summarize human factors in the past search models and with existing findings. And then we propose a novel set of hypotheses and validate them using wearable devices. After reviewing and combining the models and the existing findings, we came up with a new search models that describe how inside users' information is transformed from external environment through such stages in the information seeking process. So it generally includes 4 stages. I'll talk about them one by one. So the first stage is to realize that we have an information need. So we mainly experience negative feelings at this stage related to the feeling of uncertainties, for example, like confusions. And the cognitive activities here involve retrieve knowledge from our memory, and then regulating the incoming and updating information flow, and also some decision makings. At the next stage, we need to come up with a plan of action. So as this is about searching, it involves activities mainly related to interpreting and identifying useful keywords for search queries. So and then we are motivated and we're ready to action. In the search stage, we coordinate our output channel, like our fingers or our voice, to express the query and submit it to the system. So we are now looking forward to the system returning us our desired result. And lastly, we examine and evaluate the search results. If the result is relevant, we feel more positive and confident in achieving our goal. So this stage involves similar activity as realizing the information need, but the activity here are more demanding. And here is the full image of our new models. You can find it in the paper. And then based on the model, we formalize a novel set of hypotheses around cognitive activities and emotion. We then conduct a control lab experiment with 26 participants and collect their physiological data related to pupil dilation, sweat, heart, and also brain activity. And all participants have at least full professional English proficiency level. And to account for diverse text and voice-based systems, we also include conditions around different modalities of presenting and receiving the information, like receiving the search results via text or voice, or expressing the search query via text or voice. Yep. And we also collect subjective ratings on perceived difficulties and interests of the topic and search results, and also perceived relevance of the search results. So those are to ensure that our manipulations of the confounding factors are valid, because all this can impact the physiological signals. So our hypotheses are made based on the assumption of this. And then we calculate indexes from the physiological data and text them in the within subject setting. And in total, we test 12 hypotheses. I will show one as an example. Please find the others in the paper. So for cognitive, comparing between the realization of information need and query formulation, the cognitive activity, we look at the cognitive effort that people spend to complete a task, which is called cognitive load, and this is measured with brain signals and also pupil dilations. So information need requires a demanding effort to regulate information, to regulate internal and external information, while query formulation mainly engages in activities around the keywords. So we expect the cognitive load to be higher at realization of information need. And the results from the brain signals support our hypothesis by showing a significantly enhanced signals at information need. But the pupil dilation shows a significantly opposite trend, but this does not reject our hypothesis. Instead, it tells us that query formulations requires more attentional aspects of the cognitive load. So therefore, this hypothesis is partially supported. And we also found a significant differences in another index of the brain activity, which suggests a higher level of affective arousal at information need. So the affective arousal describes the intense of our feeling, so how strong our feeling is. So adding to our existing understanding of information seekers' behaviors, these results imply that at the beginning of the search, the participants experienced and were aware of a knowledge gap. And so we also we compare all these four stages in terms of cognitive load, effective arousal, and valence. So those two represent emotions. Please find those in the paper. And overall, our contributions for this work is that we propose a new theoretical search model based on the past user models and the existing findings. And then we propose a novel set of hypotheses to describe search stages with physiological data, and we validate them using with a lab study. And we are also the first study to explore a search process employing wearable devices. And lastly, the materials and code are publicly available. You can access them in the GitHub. Thanks.